Hello and welcome to this session, friends. My name is Yogesh Kumar. In this session, we are going to discuss about Docker containers. So this session is going to be quick introduction and basic commands. To begin with Docker, first we need to understand what is Docker. So friends, Docker is an open platform for developers and system engineers to build, ship, and run distributed applications. Whether on bare metal basically means physical machines or virtual machines or on the cloud. Please note Docker is not a Linux container technology like Xen or KVM. Docker provides an additional layer of abstraction and automation of operating system virtualization on Windows and Linux. I've listed a couple of advantages of using Docker. First one is portability. In Docker system, an application and its prerequisites or dependencies can be bundled into a single image, which is called basically image, and you can further create containers from that image. So it will be independent of host kernel and can be easily ported to different systems or different repositories. Second one, quick application deployment. As application and its dependencies can be bundled into single image, it makes quick to deploy the application. Next thing is sharing. As I just mentioned, we can share the image with the multiple remote repositories. That's again a best feature. Dockers are lightweight because Docker images are generally very small and they need very low compute capacity and storage. So they are lightweight. Easy maintenance. It's very quick and easy to maintain Docker images or containers. Another advantage is cost saving because Dockers are open source technology and don't have any heavy compute requirement. So they are basically not costly product. In case you are going with vendor support, let's say you are using Red Hat Docker technology, then you have to pay to Red Hat. But if you are using open source one, you can just take help from community. In session today, first we are going to discuss what are Docker terminologies, then Docker container and virtual machine comparison. After that, we are going to install Docker software on one of our Red Hat or CentOS 7 machine. Then we are going to discuss Docker network in brief. After that, we are going to download a Docker container or image from a repository. Basically, we are going to deploy a container. Then we are going to create our custom container and going to manage the tags and repositories. At the end, we will discuss basic Docker operations, like what are Docker states, how you can check Docker logs, how you can allocate resources to a Docker container. So begin with first we need to understand what is difference between Docker container and virtual machines. Friends, Docker containers can be created, destroyed very quickly as compared to the virtual machines. And Docker containers are very lightweight if I compare with virtual machines. Being lightweight, we can deploy more containers on a physical or virtual host at the same time and we can use them. Docker containers make use of resources very efficiently. In case of virtual machines, capacity is need to be reserved. If you remember, whenever we are creating a VMware virtual machine, for example, we are allocating 2 CPUs, 4 GB RAM, something we are reserving, right? But in case of Docker, that's not a constraint. So that's again a benefit of Docker. One of the drawback of Docker, I don't consider is a drawback, but again that's some of limitation. In case of virtual machines, they can be migrated online across different machines because they are running over a hypervisor layer. But in case of Docker, we need to stop the Docker container first before performing the migration because there is no hypervisor layer. And this is the image which I taken from Docker documentation to easily demonstrate how VM work, how Docker work. So infrastructure is your server, that may be physical server or virtual server. On that you install your host operating system. After that, there is hypervisor layer. On that hypervisor layer, you create guest operating systems like here, and on those guest operating system, you install your application. So there is hypervisor layer in between. In case of Docker, infrastructure, host operating system, and Docker engine. That is not a hypervisor, but that is a Docker engine which manages the Docker containers. And after that, there is no need to install operating system because your guest operating system is used, and your library and binaries are used by application. So that's the way Docker works. So you can see there is no hypervisor layer, and there are no guest operating system requirement. That's something Docker is quick to deploy and easy to manage. Okay, let's discuss Docker terminologies. I have listed only 3, but there are many. But in this session, I'm going to discuss about these 3. So I thought to keep the documentation limited. First thing, images. Images are template for the Docker containers. If you remember, in VMware, we can create a template that becomes a source image kind of thing. So similar thing here. Images are templates for the Docker containers. What is container? Container is a Docker entity which is created from Docker images and which runs the actual application. Docker daemon, the basic service running on the host which manages building and running container. So that's basically daemon, which controls the Docker containers and images. To install Docker, simply this is the prerequisite, Red Hat or CentOS 764-bit. You can run it on Ubuntu also. Basically, it need kernel 3.10.x. That's a minimum requirement. If you got this kernel, you can run it whether you got Fedora, you got Ubuntu, you got Kali Linux. So that's not a hard requirement to have RHEL or CentOS. Basically, my lab setup, I got CentOS 7 machine, so I'm installing EPL repository. From that, I'm installing Docker, then enabling the service. Then this is the way to check Docker version. And if you want detailed information, you can run Docker info. If you want to know what are the images available on internet or remote repositories, you can run command docker search CentOS. CentOS basically is the image name which I'm looking for. If you go to, let's say you want to get BusyBox, you can replace CentOS with BusyBox. You can say docker search BusyBox. That's a way to search images. So that was something how you can install and start the Docker. After that, I have listed a couple of lab tasks. So I'm going to demonstrate this task practically, but here that's a quick introduction. To get an image, or basically to pull an image from remote repositories, you can run command docker pull your image name. If you want to list what are the images locally on your system, docker images. To test your new image, you can run like this. To list all the containers, docker ps-a. Check Docker networking, Docker network ls. And if you want to get detailed information about particular network, you can run docker space network space inspect, then your network name. Docker stat tells what is the resource consumption by particular Docker container. If you want to set up limits, let's say you want to limit your container can use up to this particular amount of CPU, this particular amount of RAM, you can use run space it. T is basically TTY. Minus C is CPU. 256 mean because in Docker how it works, let's say you got 2 CPUs. The 2 CPUs will be counted as 1024. When I say 256, it means 1/4 of the total compute capacities. Not compute capacity, basically the CPU capacity. I'm going to use 1/4. If I say 512, it means I'm going to use half of my CPU capacity. So that's something you can manage. Minus M is I'm allocating 300 MB memory. This is my container name, and I'm running this particular command to log into container. How to stop, start, restart? Docker start container ID will start the container, stop will stop, restart will restart container. If you have made some changes into your container and you want to commit those changes, you can run docker commit container ID. What it means? This will turn the container into an image, And after that, you can tag that image using below command docker tag container ID space repo and tag. I will demonstrate this practically. Okay, next thing, how you can remove a container. Docker rm container ID will remove the container. How you can check the logs of container. Docker log container ID. Sorry, it's my mistake. I've repeated this twice, so ignore this one. Okay, next thing, at the end we will create our own custom Docker container. This is the way, like I'm just creating one dummy directory. I'm echoing one parameter, or basically this comment, into my demo webpage.txt file. And after that, I'm using docker run -d. -p is ports, like port on container side, port on localhost, minus name, what is the name of this particular container, -v. -v stands for volume, what volumes I want to map with container. So I'm saying these volumes because these are libraries, binaries and libraries. -w stands for working string, basically work dir, in which directory it need to work. As I have stored this particular text file in vad www.html, so I'm saying this is my working directory. -v again, because I want to share this one with my container, I'm saying -v this directory, and this is my container, the image which I'm going to use. After that, I'm running Python. -m stands for module. I'm saying use simple HTTP server module. This is Python module. And on which port it need to run? Port 8080. You can choose any custom port, that's up to you. And once you press enter, then you can check whether this port is listening. So you can run netstat -tupln pipetrap 8080. To test your website, simply run curl localhost this particular port and your demo page. And if you get this particular message, like this is my Docker website, then it means your website is running. So that's it. So let's begin our technical session, friends, where I can demonstrate all the things to you. Okay, friends, this is my CentOS 7 machine. Let me quickly show you the configuration which I have done. So this is CentOS 7.2 and my kernel is 3.10, which I told like that is the base requirement. Okay, now let me show you the couple of things. I have disabled firewall D. Let me quickly show you system ctl. Okay, if you see this service is disabled, and I'm not using network manager at all. And let me show you my SC Linux status. It's enabled. Let me quickly disable it. This is demo, so I'm not much worried about SC Linux, but I'm going to disable it. Okay, it's disabled, and let me quickly disable it on runtime. So I have disabled. If you see, it is saying mode from config file is disabled. So let me quickly reboot. So it will not give any issue when we are doing configuration, rebooting my system. So I'm just pausing this video for a couple of seconds till the time my CentOS systems comes back up. Okay, friends, my system came back. I just checked that it is disabled now. That's good. So let's continue with EPL repository installation first. As I mentioned, I'm going to get this package from EPL repository. Yum install -5 is for yes, and EPL release, it will install EPL repository here. So it looks good. EPL repository got installed. I am installing Docker now. So Docker package name is Docker. Okay, so these are dependencies. Let's go pick dependency list. So I believe it may take a couple of seconds, but speed is good. I'm getting good speed from my internet provider today. That's a great thing. So our Docker installation completed. If you see, this is Docker 64-bit. These were the dependencies. This package got updated. So next thing, we have to enable Docker service, systemctl enable Docker. If you see symbolically created and service enabled, let's start the service now. Just getting started, I believe. Okay, let's check exit code of command to confirm. Or other thing you can do, system ctl status Docker. You see service is running and is enabled, so that's good. And now if you have to check Docker version quickly, how you can do that? Docker space version. So this is Docker version 1.12.5 of Docker client, and Docker server is 1.12.5. So both are on same version. That's good. And if you want to get detailed information about your Docker installation, you can run docker info. This tells how many containers you have, how many are running, how many posts, how many stopped, how many images you got. And Docker server version, the storage driver, and how much data it has consumed, what is the logging configured, and what is this your system architecture, like this particular host where you have installed Docker, how much memory it got, what is the system name. My system name is Docker management. So this is the information you can get with the Docker. And next thing, friends, how you can check the available images using Docker. So simply you can run, let me clear screen, Docker search, and the image which you are looking for. I'm looking for CentOS, so let me type CentOS. If you see, these are the images available from CentOS, and these are from docker.io. And let's say I want to check BusyBox. What are the BusyBox images available? So I can write. It checks, okay, these are the images available. And what you have to basically see, this is the official image, the first one. And it got 936 stars, which is basically a reliable one. If I have to download something, I will go with official one. And similar for CentOS one. If you see, this particular first image was official one. Otherwise, some custom someone uploaded for public. Again, depend upon your requirement, you can choose the image you want to use. Let me check any CentOS 7 image. I'm minimizing it. Okay, with CentOS 7, these images are available. With Ansible, no one is official. But I'm going to download one image, CentOS/CentOS 7.1 I'm going to download. To download a Docker image, basically we have to call pull operation of Docker pull CentOS:/CentOS 7. So this will pull image from remote repositories to your local system where you have installed Docker. So this is the image size, 70 MB, and it is getting downloaded now. So still download in progress. I believe it will finish in a couple of seconds. Now extraction is in progress, so I believe it's about to finish now. Okay, so this is the checksum SHA-256. Okay, so our image is downloaded. Next thing, if we have to check what are the images available, so you can run docker space images. If you see only one image is available, this was downloaded from this particular repository. This is the tag, this is the image ID, and it was created 10 weeks ago. This is the installed size. When it got downloaded, it was 70 MB, but it got extracted, and this is the new size. Okay, so next thing, let's test whether the image we downloaded is working or not. To do that, you can run docker space run. Run means you're going to run that particular image. So this is the image name. You see CentOS, and this is the tag, and you are going to run /bin/ping. Basically inside that image we are going to run ping command, ping this opera.com website, -c count 5 times, pressing enter. If you see, we are getting response, and this communication is happening within that container now. Let me run one command quickly. Let me run uname -a. So this command is going to execute inside the container. Okay, it got error. It is saying file not found. Oh, sorry, my mistake. It need to be uname. Okay, if you see, this is the container ID. This is the particular kernel it is using, which is of Docker host where container is installed. So that's the way Docker works, because this command is getting executed. Let me show you uname -a of my system where I installed kernel. The name is Docker management, but this particular one got the Docker ID, the Docker container thing. Okay, next thing, how you can list out containers and the configuration. So you can run docker space ps space -a. If you see, these are the Docker images. Let me rerun command by reducing the font size. Okay, so this is the container ID, this is the image, this is the command which we run, and this is the status. So that's a way you can list out what you have done inside the container. Next thing, about Docker networking. Let me quickly show you one another thing. I'm going to repeat one another command, if config -a. This command is this command will run inside the container. It's giving error. It is saying Docker is paused. So let me check what happened. Basically, Docker process is not running due to some reason. I will come to this point in a couple of seconds. Let me quickly show you how Docker network work. To list out Docker network, let me show you my physical system network configuration. It got this was the Ethernet 0, which is default NIC card. This is loopback, and when I installed Docker, it created one NIC, which is basically bridge. Name is Docker 0. This is the IP on my physical system. And let me show how Docker networking works. So if you see, there are three. One is host. This is my host's physical NIC. This is the bridge. Bridge is this Docker 0. This is the network ID. And if you want to get detail about this particular network, how you can do that, Docker network inspect and network name. So network name, let's say I want to check about this bridge. What is the configuration? It is telling me this is the bridge. It got this particular range 172.17.00/16, and you can customize it depending upon your requirement. You can create a new network. You can attach a network to a running container. You can detach a network. So there are multiple things. I'm not going into that much detail, but these things are possible. Okay, so now let's run a container with resource limitations, because by default Docker can consume whatever resource on your physical system. If you want to allocate resources to your Docker container, how you can do that? For that, basically we have to run Docker run mean we are running a Docker, -it mean with the terminal, -c mean compute resources, which I discussed in theoretical session, -m memory. This is my Docker container. I'm running bash. Okay, this command finished. So let me quickly show you one thing. If you see this particular thing, the shell is changed. Now I am inside the Docker container. I'm not on my physical system. I'm inside Docker system. Let me run df-h. If you see, this is the df-h output, which is inside the container. And let me run if config command now. I believe it will give error because the command it is picking from global zone. That's fine. Let me show you. Even this command will be not there. Let me run path. The reason, because I have not exported these particular paths. That's a reason, but that's not an issue. Okay, so this is the Docker. We are inside Docker. So that's a way you can reserve resources. And let me open one another session quickly, where I can show you how resource allocation works. to check resource allocation, you can run command docker stats. So this command checks how many resources are used. This is a particular container ID which is running. If you remember, here I'm running this container, and the limit is 300 MB. If you remember, when running this container, I set the limit to 300 MB. So that is the limit. This is a total memory. This is the memory usage as of now, 4 MB, and limit is 300 MB. And this is the network IO. This is the block IO, and these are the processes. Right now, no process running, PID 0. That's a way you can check the resource utilization of a container. I am pressing Ctrl C here. To exit, simply type exit. Now you are on your management node. And let's run couple of operations. Here docker ps-a. These are the Docker images running. And let's restart a image. How you can restart a image? Or sorry, I'm correcting myself. I'm going to stop a Docker container. Docker stop container ID. So it stopped. To start it, docker start. If you want to restart it, just type restart. So in that way, Docker container will get restarted. Still in progress. Let's wait it to finish. Okay, it finished. It got restarted. So that's a way you can restart, stop, start a container. Let me list the images. Docker images. Okay, right now I got only one image. Let's say I want to create my own image from a running container. Right now, if you remember, this container is running this particular container ID. I want to customize it, let's say I have updated something in this container and I want to create an image now. How I can do that? Docker commit and container ID. Once you do that, this is finished now. Let's run docker images command again. If you see, one new image ID is created. Earlier it was not there and it created 5 seconds ago. So that's a way you can create your image. But one thing you may be wondering, why repository is none, tag is none. Basically we can tag it and set a repository. To do so, we have to run docker tag command, and that can be done with docker tag image ID, and let me make repository. Here I have to specify repository. I'm saying this is Yogesh test image, and colon I have to put tag. I'm saying this is demo image. So let me run docker images. If you see now, here this particular image got tag Yogesh test image, and this is the image ID and it got this particular tag. So that's a way you can create a docker image, and you can export this image to any repository, or you can make a tab also. There are multiple ways. How you can remove or delete a container. For that, let's say this is our container ID and I want to remove it. So docker rm and container ID, press enter. Here I'm getting error. You cannot remove a running container. Okay, because this container is in running state, so I have to stop it. Otherwise I can use -f. Let me use -f. If -f mean force, which forcefully I have deleted the container. Otherwise I can stop it first, then start the container. So that's a way you can destroy or remove a container. Okay, let's check the containers again. Okay, so this is the container which we got currently. It is created, and let me run this container. To run a container, basically I have to specify its container name, and I have checked my status. It is running now, And let's quickly do one test. I'm again going to run container command to ping opera.com. Okay, it is able to ping. And let's say, friends, you have to check logs of your container. How you can do that? Docker space logs space your container ID. This is my container ID now. Right now there are no logs available for this container. Let me run docker ps-a. Okay, let's check for this one, because this was the container under which I run this ping command. That's the reason I have to specify this ping ID, sorry, this container ID, and I am sure it will revert something. Okay, if you see from logs I have pinged this particular thing. So in that way you can check the logs of your container. These are not complete log, but again you can get something. So the way I did. Okay, let's do one thing. Let's create our custom website using Docker containers. How we can do that? I will quickly demonstrate you. Let me clear my screen. We already got one container image which is sent to S7, and I'm going to use Python module named simple HTTP server and going to run one website on port 8080. Okay, first thing I have to do, I have to create a directory on my server. Let me show you. I haven't got Apache web server. If you see, I don't have Apache, but I'm going to run a web server using Python's simple HTTP server module. So I'm creating a directory with var www.html. I'm going to echo some string in demo webpage.txt file. This is Yogesh, that's Docker website. That seems good. Okay, so I got this particular text inside this file. Okay, next thing, friends, I have to run a Docker. Here I'm saying docker run -d, -p mean port 8080. Why I have specified port 2 times, which port need to be used inside container and on the physical host side. So that's, I'm saying use same port. After that I'm giving a name, Python web, and -v means I'm saying this is my volume. Volume means the volume which need to be exported to container. I'm saying user has been need to be exported as user has been. -v user bin need to be exported from physical system or the system where I install Docker, and on Docker container it need to be user bin. So that's a way, like that's a formatting. After that I'm saying user lib64 also need to be exported from the physical system to the container as user lib64. Then another directory I need, I have to tell this is my working directory. Working mean where I got my configuration file, this particular one. I'm saying -w, this particular directory. Then I'm saying export this particular path, because my container cannot access this path if I am not exporting it. So I'm saying export this path also. And which particular container to use, I'm saying use CentOS one, which I had just downloaded before the start, during the start of the session. Then I'm saying which command to run. I'm saying run Python command. Okay, if you are running this demo, you need to have Python installed. I forgot to tell that, but I thought to tell you now. And which Python module to use. I'm saying -m simple HTTP server on which port, 8080. Pressing enter. It is saying unable to find image lit test. Okay, something missing in my command. Let me quickly have a look. Okay, so I got error here, friends. I have missed minus, which is the reason the command is getting failed here. It's a good thing we are getting error, so let's try. Okay, if you see this time command finished, and let's check whether on my physical machine it is listing or listening on port 8080, because I just started the server on port 8080. Okay, if you see, it is listening, and this is Docker proxy. Okay, let's test our website. So I'm going to use curl localhost on port 8080 and this particular web page. If you see, I got my message, it means my website is working. So that's a quick way, friends, how you can create your own website. And let me do another thing quickly. Okay, so this is the container ID where I run this Python web server, right? This is the container ID. So let me commit it. And this container ID. So it is committed. Let me tag it now, because tagging is again important, friends. I'm going to tag now, Docker tag this particular container ID. Basically, this is now image. So I have to specify image. Let me check what is the image ID. Docker images. I'm repeating. I know you might be getting confused. When I committed it, I committed with container ID. But once commit is complete, it turns that particular container into image. Container will be still running, but again the image gets created. If you see, this image got created 27 seconds ago, and now I have to tag this particular image. So Docker tag this image. I'm saying this is Yogesh repository, and this is Python web, and I'm saying here need to be slash because that's a format, and I'm saying this is my lab Python web server. Okay, image got tagged. If you see, this is the information now. This is Python web and this is my tag. So it means image is created. That's a way like you can create your own Docker images. So that's it in this session, friends. If you have any query, any suggestion, or any feedback, please leave a comment on my YouTube channel. And this session, I know that is not a very advanced session. This is only for basics, like if you guys are not aware what is Docker, how images work, how to run Docker, how to run containers, how to create images, how to check resource utilization. So these are the things which we just discussed. So basically you have to learn more things about Docker. Whatever I discussed, that's very basic, but this can be a base for your next learnings of Docker. Thanks for watching this video, friends.